Here in this video we're going to look at the basic rules for taking derivatives, and the first rule is the constant rule. Now before we get to that, I have this notation d dx, and I said that this notation means taking the derivative of a function with respect to x. And here all of our functions are going to be with respect to x until we get later on in this course. So anyway, the derivative of a constant, so any fixed number, is equal to 0. And an example of that would be the derivative of 5. And the derivative of 5, or f prime of x, remember, once we take a derivative, we're going to call it f prime of x, or we could call it dy dx, which is the same as saying we're going to take the derivative of the y function with respect to x, and in this case the derivative of 5 is equal to 0. The next rule we have is the general power rule, and this one's going to be important. We're going to use it very frequently. It's d dx of x to the n is equal to n times x to the n minus 1. So essentially we're going to multiply down, or move down, the exponent in front of the variable and then subtract 1 from the exponent. So an example of that would be if f of x is equal to x cubed, then f prime of x is equal to 3x squared. And the next rule we have is the constant multiple rule. So if you have a constant, the derivative d dx of cfx, we can move the constant out front and then take the derivative of the function just like we did in the power rule example above. So f prime of x here is going to be equal to 5 times d dx of x squared, which is equal to 5 times 2x, or 10x. And we don't have to keep rewriting it. It's important to understand that this happens. But what we're going to do in most cases is multiply the 2 times the 5 to give us the 10, and then subtract 1 from the exponent to give us x. But that's generally how the rule works. And then the sum rule is d dx of fx plus or minus g of x. So we never take a derivative through a plus or a minus sign. So you're going to take the derivative of each piece individually. So if we have f of x is equal to 4x cubed plus 7x, we can say that f prime of x is equal to 3 times 4 is 12, subtract 1 from the exponent, x squared, and then plus, now 7x is the same as x to the 1, so 1 times 7 is 7. And if we subtracted 1 from the exponent, we'd have x to the 0, which is equal to 1. So anytime you have a single variable and you take the derivative of it, it just turns into the constant that was out front. So those are our basic rules for this section. And I just wanted to go through some algebra reminders, how to move an exponent around. If we have 1 over x to the 5th, that's equal to x to the negative 5th. So if the exponent is positive in the denominator, it becomes negative in the numerator. And we're going to need to be able to interchange them and write them both ways. So my next example was 3x to the negative 2, which is equal to 3 over x squared, because the exponent was negative in the numerator, so it became positive in the denominator. And the other thing I wanted to do a reminder of is roots. So the square root of x is equal to x to the 1/2. And then the other example I have is the cube root of x squared. Just remember that whatever the exponent is on the variable inside the root is going to go in the numerator. So we have x squared, so the 2 goes in the numerator, and then the cube, because it's cube root, we have a 3 in the denominator of the fraction. Now let's look at some examples. So I did those reminders because oftentimes it's not written in a way that makes it easy to use the power rule. So we're going to start by rewriting the function. So here, instead of going right into taking the derivative of f of x is equal to 1 over x cubed minus 2/3 x to the 3/2 plus the square root of x plus 7, I'm going to rewrite it in a way that will make it easier for me to use the general power rule. And that means bringing all your exponents, all your variables up to the numerator. So we're going to have 1 over x cubed I'm going to rewrite as x to the negative 3. I don't have to do anything to this second term. Just rewrite it. I'm going to write the square root of x as x to the 1/2 plus 7. And now everything is in a form where I can use the derivative rules, the power rule. So f prime of x is equal to, we multiply down the negative 3, so negative 3 x, and now we subtract 1 from the exponent, so we get negative 4. Minus, now we have 2/3, and now the derivative of x to the 3/2 is 3/2 x, and we subtract 1 from the exponent, leaving us with 1/2. And then x to the 1/2, we're going to multiply down the 1/2 and subtract 1 from the exponent, so we get to the negative 1/2. And then the derivative of 7 is 0, derivative of a constant. And now many teachers are not going to want you to have negative exponents in your answer, so I'm going to take the time to rewrite this without any negative exponents. So we get negative 3 x to the 4th, and now we have 2/3 times 3/2, which is equal to 1. So I have minus x to the 1/2, and then I have a negative exponent in the next term, so again I'm going to move it to the denominator and make it positive. 2x to the 1/2. Alright, so in the next example, I have f of x is equal to negative 1 divided by the cube root of x to the 5th plus pi x plus x to the 1/7. And again, I'm going to take the time to rewrite it. So f of x is equal to negative. Now remember that the cube root of x to the 5th could be equal to x to the 5/3. And x to the 5/3 is in the denominator and it's positive. So when it comes to the numerator, it's going to be a negative exponent. So we have negative x to the negative 5/3 plus pi x plus x to the 1.7. And now when we take the derivative, we have f prime of x is equal to, and we have a negative out front, and then we have a negative 5/3 coming down, and x, and now we subtract 1 from negative 5/3 and we get negative 8/3. And the next term we have pi x, and remember pi is just a number. It's equivalent to 3.14 and it goes on forever, and it's times a single x. So we're going to have plus, and remember x to the 1, we multiply the 1 down, so we end up with pi x to the 0, and x to the 0 is equal to 1. So we don't have to write x to the 0. And then here we have a decimal, and it works just the same way. We bring the 1.7 down, x, and then we subtract 1 from the exponent, so we end up with 0.7. And again, I'm going to take time to rewrite this and get rid of my negative exponents. So f prime of x is equal to 5 over 3x to the 8/3 plus pi plus 1.7 x to the 0.7. Alright, and I have one more example, and I wanted to do this example also as an algebra reminder. I didn't put it over on the other page, but remember when you have a series of terms across the top and a single term on the bottom, you can rewrite this as 3 different fractions. So what we're going to do is think about this function. So I have f of x is equal to 3x squared plus 6x plus 1 all over 3x, and I'm going to think about this as 3 fractions. Plus 6x divided by 3x plus 1 divided by 3x. And now I'm going to simplify each term. So f of x is equal to 3x squared. The 3's cancel each other out, and if I have x squared on the top and x on the bottom, it leaves me with a single term of x on top. And then I have 6x divided by 3x. The x's cancel, and 6 divided by 3 leaves me with 2. And then I have 1 over 3x. And I can rewrite that as 1/3 x to the negative 1, because the x was positive, the exponent was positive in the denominator, and it becomes negative in the numerator. And now I'm in a form where I can use my power rule. So f prime of x is equal to, the derivative of x is 1. Remember, x to the 1. So we multiply the 1 down, and we take 1 away from x, which is x to the 0. The derivative of a constant is 0, so the derivative of 2 is 0. And now we multiply negative 1 times 1/3, so we end up with negative 1/3, and then we subtract 1 from the exponent, x to the negative 2. And now we're going to take time to rewrite it, get rid of our negative exponents. So we have 1 minus 1 divided by 3x squared. And that's it for this video.